Hey all, it's Sophia, and welcome to episode 1 of Environmental Science. And today's focus will be on estuaries. So, whenever you see this pause symbol, I want you to pause when it's indicated. So, before we proceed with the lesson, please download episode 1 skeletal notes, which would be supplemental material number 1. And you may download and/or print these skeletal notes as a guide during the lecture, and I highly recommend doing this. So, as I do the lecture, you can fill in the blanks of the skeletal notes, write down or jot down any other interesting information, and hopefully helps you adapt a more active role in learning rather than a more passive role. So pause and do this if you haven't done so. Okay, so let's proceed with our learning objectives, or LOs. And the first LO of every episode from this point on is Plant of the Day. And yes, I will be doing it in a singing manner because I love plants and I'm very excited to talk about them. And the reason why I incorporated Plant of the Day is because I realized that during my intro video, I quickly talked about rare and unique plants that I encountered with my mom, and I didn't really get to shine a spotlight on them. So I hope that Plant of the Day does justice regarding the plant's beauty, and I hope that it'll get you to start taking care of your own plants and starting your own plant journey. So after we do Plant of the Day, we're going to learn how to classify estuaries based on geomorphological features and water circulation patterns. And then afterward, we'll learn about how estuaries are formed, and it kind of ties into the geomorphological features and water circulation patterns classification learning objective. And after we learn about those classification and formation features, we will learn about the famous estuaries that still exist in the United States. It's time for Plant of the Day, episode 1, and we're going to talk about the Philodendron Pink Princess, which I briefly mentioned in my intro video. So this is the Philodendron Pink Princess. She's very pretty. Here's the one we have. It's a baby, it's very small. There's me. And this is a close-up of the Pink Princess. You can kind of see a Hoya rope, which will be talked about in a future episode. But for now, let's focus on the Pink Princess. So the botanical name of the Pink Princess is the Philodendron erubescens, and it's characterized by the beautiful dark green and pink leaves, and also has a waxy leaves, if you kind of see in the image. And the leaves can grow up to 9 inches long and 5 inches wide. And you can see I'm holding a baby. I don't have big hands, so it's a very small one. And these phyllos are tropical plants that also grow well indoors. So if you take care of a philodendron, whether that's a pink princess or other types, I recommend putting them in a region with bright light, but shaded so they don't get damaged by the direct sunlight. So I'm proposing a question for you. And why do you think it's both pink and green? And why is it just not all pink or all green? So pause the video and try to answer the question. So if you talk about chlorophyll in your answer, I'm very proud of you. Great job. And the reason for the pink appearance of the Philodendron Pink Princess, these regions of the plants actually lack chlorophyll, which is the organelle needed for photosynthesis, and which we will learn about in a future episode. And the dark green is full of chlorophyll, and the chlorophyll is known for the characterizing green color of the plants. That's what gives plants their dark green color. And that's the reason why you have these two color regions here. And with that in mind, it's really important to talk about plants that you might think that are the pink princess, but they're not, kind of like knockoff pink princesses. And so this is actually not a pink princess. This is better termed as the pink Congo. And these all pink leaves are not 100% natural. Professional botanists and other professionals in general, they insert and they inject these leaves with a substance, and it induces the entire leaf to turn pink. But the pink color actually goes away over time, and you end up getting a more characteristic looking pink princess. So be very careful if you ever encounter a pink Congo, it's not a pink princess. So that's another fun fact for today. And I hope you enjoyed Plant of the Day. And let's move on to more environmental science focused topics. So before we get into the nitty-gritty of the event, we should probably know what estuaries are. So estuaries are partially enclosed bodies of water that are typically located where the rivers meet the sea. And the rivers meet the sea statement is a common a statement associated with estuaries. And because of the river water meeting with seawater, you end up getting a mix of water called brackish water, which is a primary reason for the high productivity and the high uniqueness of both plant and animal communities in estuaries. And brackish water, like I've mentioned, is the actual term for the mixture of fresh water draining from the land and salty seawater. And because of the mixing of the fresh and salty water, you can get this wide salinity range for estuaries. You can have a 0.5 to 35 parts per thousand salinity range. Parts per thousand, or PPT, will be a unit that we will greatly discuss in the mathematics portion of the event, so stay tuned. And an interesting statistic, 22 out of 32 largest cities in the world are located in estuaries, and one of them is New York City, or the regions near New York City. All right, so let's talk about another example of an estuary, the Gulf of Mexico. And with this example in mind, do you think that estuary salinity stays the same for all estuaries, or do they vary, and why? So pause the video and try to answer the question. So if you answered they vary, you are correct. In addition to salinity in general, there are other factors that affect estuaries and the resulting salinity, such as tides, weather, and even the time of day. And to go more into tides, which are the rise and fall of the sea surface, most areas of Earth experience 2 high tides and 2 low tides. However, the Gulf of Mexico only experiences 1 high tide and 1 low tide, which affects the salinity of the Gulf of Mexico. So the next learning objective is focused on classification, and also formation. And there are different ways to classify estuaries. So you can classify them based on water balance, geomorphology, geo meaning earth, morphology meaning shape, so shape of the earth, and vertical structures of salinity and hydrodynamics. I'm not going to go in depth with these 2 right here, just because it's not part of the syllabus or you're not expected to learn. But I just wanted to raise awareness of the existence of these 2 classification types. So let's go in depth with water balance. So there are 3 subtypes for water balance classification. The first one is a positive estuary. And in a positive estuary, you have freshwater additions from river discharge, rain, or ice melting, exceeding the freshwater losses from evaporation or freezing. So if you look at this diagram of the positive estuary, you have a large outflow of river going towards the ocean, and as a result, a longitudinal gradient is established. So it's a fancy word for saying that there's a great outflow of water from the river to the ocean. So if we have a positive estuary, there is no surprise that there would also be a negative or inverse estuary. So in an inverse estuary, these are usually found in arid regions, which would explain the high rates of evaporation, exceeding the freshwater additions from precipitation or rain. So let's look at the diagram right here. You have high evaporation and negative water balance estuaries. And as a result, you have a really low density here. So this is the symbol for density. And the density increases as you go towards the land. And lastly, we have a low inflow estuary type. And this is characterized by high evaporation rates, but with a small influence from river discharge. And as a result, you get this really interesting density distribution. So with the density being the greatest in the middle between the ocean and the river, and density changing, going outward. Okay, The second classification type that I will be focusing on in this lecture is geomorphology. Like I mentioned, the shape of the Earth. The shape of the Earth, or the shape of the land, the terrain, is another classification type that's very useful. So for a coastal plain, it's this diagram right here. These estuaries are formed during flooding over several millennia by rising sea levels. And if you can look at this image, you can see that it's much wider than present-day rivers. And an example would be the Chesapeake Bay and the Delaware Bay. You'll be expected to know how to identify the Chesapeake Bay, and we'll learn about what it looks like in the last few slides of this presentation. Okay, so fjord, the American pronunciation for this word right here, is associated with high levels. It's associated with high latitudes where glacial activity is intense. So it's also characterized by an elongated deep channel with a sill, and those sills are usually also associated with the moraine, which are left over by glaciers. These are indicators of glacial activity. Instead of staring at this picture and it's kind of hard to visualize, I recommend looking at pictures of moraines and fjords on Google so you can get a better visualization of this glacier associated estuary. So bar-built estuaries, they're also called embayments, and they're semi-enclosed by a spit, which is formed due to littoral drift, and it separates the coast from the ocean. So to reiterate, a bar-built estuaries or embayments are partially enclosed, and examples are Florida, and North Carolina. You can find bar-built embayments. And lastly, I think this is my favorite, it's really interesting, are the tectonic estuaries, and they're formed by earthquakes or by fractures of the Earth's crust. So whenever there's some sort of tectonic activity, the one related to tectonic estuary formation, when the plate tectonic activity occurs, there could be a basin that forms as a result of the tectonic activity. So there's like a sinking of the Earth's crust or the Earth's uppermost layer. And as a result of the sinking, the ocean can fill the basin with water, and that water/basin combination, that ends up becoming the estuary, which I think is really interesting. And famous examples of tectonic estuaries, the San Francisco Bay, which you are also expected to know in identifying, and the Manukau Harbor. All right, so the last learning objective for today is learning how to identify famous US estuaries. So instead of actually quizzing you in identifying US estuaries, I'm just gonna do a quick introduction with them, and I recommend that you do your own research in how to identify these. So this is one that you're expected to know, and try to pause the video and try to figure out which estuary this is. So if you said the Kachemak Bay, you are correct. This is located in Alaska, so uppermost part of the United States, and it's really indicative of these snow-filled mountains, very beautiful. So Kachemak Bay. All right, second one. See if you can identify this. Pause and try it out. So if you said the Hudson River, you're correct. And you can use this bridge as kind of a guide in IDing the Hudson River. And you may be thinking, rivers aren't estuaries, estuaries aren't rivers. Well, remember in the first part of the episode, I was like, estuaries are commonly associated where the river meets the ocean. So that's kind of an explanation as to why this is acceptable. Okay, I mentioned this estuary in our lecture as well. So try to look at these images and remember the lecture, pause, and try to figure this out. So if you see the Chesapeake Bay, great job, you're correct. And Chesapeake Bay, if you remember, is a type of a coastal plain estuary. And the coastal plain estuaries are kind of like rivers, but a little bit chubbier, fatter, and wider in terms of size. So very beautiful. This is an aerial view and more of a like a satellite view and also an aerial view right here. Last one, best one. For my Cali people watching this, this should be an easy one to identify. Pause and try it out. You said San Francisco Bay, you're correct. And the Golden Gate Bridge gives you a hint that we're in California looking at the San Francisco Bay. This is a satellite view of the bay. It's really beautiful. And if you can remember, as I mentioned, the San Francisco Bay is a type of my favorite type of estuary, the tectonic plate estuary, which is a subclassification of the geomorphology classification. Okay, so to summarize our episode, we learned about what estuaries were, characteristics, and the role of tides in affecting the salinity of estuaries. We also learned how to classify estuaries based on geomorphology and water circulation or patterns. And lastly, I showed you some nice images of the famous estuaries in the US. You will be expected to know how to ID these estuaries, so I recommend making some sort of Quizlet with different images of these estuaries, and this will be fair game on the exam if you choose to compete in the online competition. So these are relevant readings and resources that I use and I recommend you look over. So most of my information was from the NOAA, and supplement 3 and 4 are also very nice information that you could use or read over to become more comfortable with the episode. And these are my citations, and I hope that this was a fun first episode, and I hope to see you in the next one, which will be focusing on oceans and laws that protect marine environments. Bye, guys.